and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am 𝗖𝗲𝗄𝗂𝘂𝗃𝗂𝗃 and I'm the Director for Community and Partnerships with OpenWeaver. OpenWeaver is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AR-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, Pooja Agarwal, who is a senior developer advocate with OpenWeaver.
Hello everyone and welcome to this session on building your own image restoration engine. We will discuss how generative AI based models can help you restore your old photos and create interesting colorizations as well as upscaling and enhancement in your images. So let's get into the agenda for the day. We will talk about the problem a bit and how we would want to restore it using technology, and then we'll also do a simple code snippet exercise to augment your knowledge and suggest how you can do many similar coding exercises on kandi. We will then move into our solution source, which is on image restoration today. So before we go ahead and discuss the concepts for the session, we will now head over to check out the solution today. Let's first see what exactly our solution is capable of. So I have this radio interface which should be visible to you, and this is my Jupyter notebook. I've just loaded it, and this is what you're going to set onto your systems. I'll discuss each and everything step by step. For now, I want to show you the capability of this kit that you're going to work on. Let's say this is one of the image that I've already given as input, and this was the colorized image that I got from it. So let me showcase you something different. Let me just first clear this output and then try and showcase you any other image that we could use to restore. So I'll pick up this pick up the image from where I have this model set up onto my system. I've created a folder called input images here. So you can choose any of your images which are grayscale and try checking those. So let's say I will just pick up this image and try to just submit it to the model and see how well it is able to colorize this particular image. So this is an image of a woman, who's just moving around from country to country and with some kids. So we just want to check out whether our model is able to restore this image, color it, and give us a uh, colorization which is good enough through this model. So we've used two models here. We've used 𝗖𝗲𝗿𝗁𝗂𝗂𝗂 for colorization, and we have also used another one for enhancement. So the model does take a bit of time to get us to the output. However, uh, the good thing is with this model, we we get very close to colorization of a colorization index of images in where we get decent sharpness and amazing results. So we'll just wait for this model to get us to the result in a minute. So yeah, you see that even the size, if you look at the kind of colorization it was able to put through into this image. So it actually looks fresh, and it does give us a very interesting output. So similarly, we have an option for enhancement as well, where we will discuss how you can enhance image, upscale the size, the resolution, as well as the image quality. So that is something that I'll showcase you. Let's first now get up into the setup of this kit. That way, you will be able to also set this kit alongside with me as I am discussing today. So you would be currently viewing this session on OpenWeaver's community page. And if you scroll down, you'll be able to see that there is a resources section under which we have our Kandi one-click kit. So go ahead and click that. I will also like to tell that this is one place where you go and take your assessment post the session. Also, you have an option to collect a open source enthusiast badge. Very simply, you can take this badge. Just follow the steps that I'm going to showcase you now, and then try to tinker a little bit with the code. I'll also be suggesting how you can tinker with the code, and then submit a screenshot of what image you tried colorizing, what images you tried to upscale and enhance in quality. Just reshare that with us here using the reply option, which will be available to you if you go ahead and use this chat feature. Sorry, if you go ahead and log into the community platform, that way you will be able to reply, get this option activated, as well as an option to also chat with us directly for one-to-one resolution of any of your queries. So yeah, these are some polling questions that you can interact with and see how others are also responding to these questions. So now quickly let's get into our solution. So click on this Kandi one click it. It opens this page for you. Here we have listed down the deployment instructions. So you can use these instructions if you are currently not on your laptop. And for operating systems apart from Windows, you can follow alongside with these instructions. So I will go ahead and try setting this kit up. This will download a zip file onto my system. Then I would say show in folder. I will try and extract the contents of this zip file, and I'll get a folder within. So very essential to extract the contents before you go ahead and start setting this batch file onto your systems. So extract it and only then double click and say more info, run anyway. So this will start setting the required dependencies, your Jupyter notebook, your libraries, everything. It will automatically set up for you. So this kit has two models, and since it is these three pre-trained models that have been used here, it may take some time initially, but depending on your bandwidth, it won't require above than 10 minutes. So let it set up onto your systems, and in the meanwhile we will discuss the concepts for this session. I hope the process for setup was clearly understandable. Okay, so we want to talk about how you can restore your old images. So computer vision is a very interesting library that is available for making changes to images, for capturing your video. So I want to talk about something a bit beyond this. Let's say you are interested in colorizing old movies. So That's something that computer vision library is also capable of up to a certain extent, where it would help you with capturing people in motion, help you provide some special effects, can give you some computer generated images, right? So the only thing that we want to talk about and put your focus around today is, you must have seen in a lot of movies where there are some FBI and CIA agents who try to look at an image of someone they are chasing, and they sort of this they see that the image is sort of distorted, or it's difficult to figure out exactly who is there in the image, and then they call a tech guy, and they ask that guy to enhance the image, to improve the quality of it, so that they are able to see the bad guy's face. So the enhance is what we are trying to do as one of the features of this kit that you can work around with today. And also, this enhancement which we are saying this our model will provide, it somewhat is like putting a pair of glasses which you can't see without, right? So you can't see without a pair of glasses, and that kind of clarity won't come. So similarly, we want to talk about how we can use interesting models. So talking about this image, if you see an image like this which is completely grayscale, can also be enhanced to another interesting image like this. I mean, can also be colorized to an image which you can see on the right. So this is what we are going to talk about today. We have a model called de-oldify. This de-oldify model, this is used for colorizing your black and white images, and this became popular as it uses GAN, or your generative adversarial networks, iteratively between two neural networks. So it is being used iteratively between two neural networks, and it was introduced by your Jason Antic and Dana Kelly. So these guys introduced it around 2000, in the year 2018, and since then they have been improving on its functionality. So there has a lot that has been improved, and today, with these generator and discriminator, which are your two neural networks, we are able to get two images which show the power of GANs. They are able to bring colors. So what does the generator do? It applies colors to the recognized objects. Okay. Let's say there are different images on which this generator is being trained on. And what does the discriminator do? It tries to criticize the color choice. So that is the model that they work on. The generator tries to apply a color as it recognizes the object. The discriminator tries to criticize the color choice, and hence they try to get to an optimum methodology that could help in getting to as good as color possible. So this is based on the fast AI library. Also, this model, this de-oldify model, it is highly capable of adding vibrant and realistic colors to historical images or grayscale images, all your old images that you may have and you would like to colorize, you could do that. And then it also preserves the fine details, the texture, the sharpness, all that actually helps you enhance, or let's say process your images in a better manner. So the training process, it's an iterative process which involves improving both your generator and discriminator. And exactly in the training data, what happens, there is a large scale data set of color images which are used for the training of this de-oldify model. So that has historical and contemporary images from various sources, and the data is curated in such a way that there is quality and decent diversity in it. So Deoldify is able to produce visually stunning and vibrant colorizations, and it is able to we can see achieve impressive accuracy in preserving the original image's characteristics. So as we are colorizing, it is not uh, you know let's say it's not removing any specific features or characteristics. We can fine tune the colorization results as per our preferences also, if required. So what are the features and upgrades? If you see, there are a lot of upgrades that have happened in Deolify. The glitches and the artifacts, all of those are completely eliminated. You're able to see better skin, human skin, colored skin, so fewer zombie looking images. There is less of blue bias. So this blue bias was something that sort of made it look not very interesting when we tried to colorize. And you can actually pick up your old parent images, click and upload here and colorize them. So and then download them and get that printed on an A4 size paper if you would like. So they are like more highly detailed and photorealistic renders that are possible with the latest deoldify or the model that we have used in current notebook. In fact, as an extension, you could go ahead and also check to work around with the video. Also, it uses no-GAN. So this no-GAN is an effective way of training your generative adversarial network for image to image response. So if we go into too much detail, then we discuss how no-GAN basically helps in enhancement, or let's say colorizing the image to a great extent. So we talk about image upscaling and enhancement. And as we talk about this upscaling and enhancement, we are using the generative facial prior, okay, or let's call it your GAN based GFP, which is a state of the art AI model for improving the image resolution, enhancing the quality, or let's say in fact removing the blur. I'll show you this enhancement as well. It was developed by researchers in the field of computer vision and deep learning, and it was able to improve the visual quality and details of your low resolution images. So this utilizes GANs for realistic and high quality image generation. What is the exact framework? If you see the images here on the right, so the below images, if you see, there were various corrections that came up. Okay, not just the first image being the input image, and then the modified image, which is the second one, and then the third one. So the third image, which felt a little bit more, I would say, clearer as compared to the other images in this particular pictorial view of this image of different persons. So basically, it targets the facial features. If we are talking about this GFP, your facial prior algorithm, what it does, it targets your facial region or your face, and basically what it tries to do, it tries to remove the degradation from the artifacts of the faces, the expressions, etc. So they just leverage, they use the pre-trained GAN and spatial feature transform to restore your facial details with a single forward pass. So the interesting thing is that with a single forward pass, they are able to get us ahead in this journey of image restoration. And what is the process that is being followed? Using the channel split spatial feature on your transform layers. So we want to talk about multi-layer perceptrons that are used, which allow for a good balance between realness and fidelity. So the realness should be maintained enough, and the the degradation removal module, which is a unit, that is being used alongside with the pre-trained face scan as a facial prior. So within this, there are steps that are being followed while we use this pre-trained model, and they are bridged by latent code mapping. How are we combining the effects of these two models? They are being combined using this, I mean, this channel split spatial feature is being code mapped, and then the transform layers are used to showcase the results. So your GFP-GAN could jointly restore facial details and enhance colors with just a single forward pass. That's what I'm trying to focus on. So not a lot of effort had to be made, multiple passes to get to a good quality image resolution, as well as a specific optimization at the image inferences. So the process that is being followed, you during training, we intermediate restoration happens, that is employed to remove complex degradations. The facial component loss, let's say the image is blur, etc. So with discriminators is used to enhance facial details, and the identity preserving loss is used to retain face identity. That while we are trying to enhance the image, we do not just lose the identity of the face. So that is also something which is highly a key priority when we are working around with the solution. And you always want to go with open source solutions. So we want to talk about how you develop quickly. You use open source libraries. So all of this kit, the entire kit is open source for you to use, and you can redistribute it to other people as well. And whenever you are using such libraries, there are four key considerations to take care of: support, security, quality, and license. So you check whether you have the decent required support within that library. The security is good enough. There are no backdoor options to get bugs into that library. The quality and the license, etc., is also necessary. Whether the license is permissive, wherein you are able to use it as per your need. You don't have to give it back to the community. So now let's get into your image restoration kit, and let's see what is there within the code. So once you have successfully set up, this Jupyter notebook should open for you. You just have to say restart and run all. That way your kernel will run and load all these essential libraries. We first done import for your operating system. Then we have imported your CV2 library, which is your computer vision library. Next step, we are using Gradio, which is used to create interface, which is the outline where you are loading the model, where you are uploading the image and then getting the output. All that outline interface is being loaded with the help of Gradio. Then you have Torch. Again, Torch is used for alongside with image to load this interesting models. We are also using Paddle Hub to load this deoldify model. So Paddle Hub has a lot of various, hundreds and thousands of pre-trained models that we can load from. So that we are loading as well. Then you have from your GFP we want to import your facial prior GAN for using it for face enhancement. Then obviously from Paddle Hub we are using it to load your deoldify model. And then there is pathlib for setting the path, etc., saving the path, and the date time as well is imported. And lastly, we are doing an essential import for image. So first of all, from the hub.module, we load our model into the model variable and set the render factor as 75. So after we have done the necessary checkpoint and loaded our pre-trained model, we have two functions. One is your colorize image and another is your inference, which is used for upscaling, and this one is used for colorization. So here what we are doing, if a path does not already exist for your output image, you make a directory or a folder called output, and then whatever image has been, this colorization model deoldify has been applied on the image that is being stored in the result. You store the output in output deoldify image as an image.png and save that as well in a file. Then you open the image and store it in img and then return the two imgn file as tuples. So further, when we talk about the upscaling and enhancement, here we have a function where you pass the image and then the scale. Let's say the scale is your, let me show you the scale, your rescaling factor. So by default you can set it to 2, that is already there in the code. And you can, if you would like, you can also increase the scale. That will help in setting the resolution of the image. So from the os.path.split text, we are splitting the image extension. So let's say the image is .png, .jpg, whatever the extension is, we are saving it in extension. And then with cv2.imread, we are reading the image and reading it in an unchanged manner and storing it in img. Then we are checking this particular image for three essential parameters or features. We are checking for the width, height, and the channel that the image has. So if it has all these, if that image is equivalent to 3, then it is already a RGB. We are setting the mode of that image to red, green, blue, and alpha. And we are accessing the channel also. So if the image channel, like what the channel is used to set the, if the image has 4 channels, then we say that the image is RGBA, all the 4. When you similarly check the image, if the length is this, then the image mode is set to RGBA. Else, if the length of the image and the shape is equivalent to 2, then you see that, then you understand that you have got a gray scale image or a gray scale input with black and white as the color. So you just don't set any mode, but you colorize the image, and you use the cv2 color here, um, and then cv2 color underscore gray to bgr. So your BGR is your blue, green, and red. Gray to BGR. That is one of the other modes. We have multiple image modes which we want to set the image in, that we have set here. And rest, if these two conditions are not met of for the image shape, either the channel size is 4 or either the channel size is 2. Apart from this, whatever is the channel size, then the image mode is again set to none. And further, after that, we will check the size of the image. Sorry, the height and width of the image. And then if the height is less than 300 pixels, then we resize the image by interpolating it and saving that resized image in img. We then apply the facial prior algorithm for enhancement, where we are setting the model weights here into the model path. The upscaling we are setting to 2 by default, and arch we are keeping clean. Channel multiplier is also set to 2. After this, we use the dot enhance, face underscore enhancer, where we had loaded the model. This model, we call it using the dot enhance function, and within this we put it across our image. The has aligned feature we set to false. Only if we have multiple images in the folder, only the center face is being enhanced, so we set all that to also false. And paste underscore back, we are setting this to true, so that we are setting to whatever it is already. Then further, we we are this is within the try block. So in case of a runtime error, we print the error for the output, let's say. And then if scale is not equal to 2, then what we do, we check the images area, and if scale is less than 2, or else if it is we have used the lens z z0s4 to reshape or interpolate the image. So again, we check and resize the image as we had done before by setting the interpolation for the image to 2. I mean, to greater than, I mean, whatever is the width that we have multiplied with the scale that we had mentioned earlier, and accordingly divided by 2. And accordingly, we get to the output, the enhanced output, the upscaled output. And just in case there is an exception, we will say a wrong scale has been inputted and an error would accordingly be showcased. And if image mode is RGBA, then it will be saved in the PNG format, extension will be PNG, else it will be saved in the JPG format, whatever is the output extension, I mean whatever the output image, which will be saved with output dot extension. And then you write all of this into the safe path. Your output, you finally return the output and the saved path, and also check for any global exceptions if there are in the image supplied as well as the scale. So these are the two things that get into this function. Then we have this gradient interface, which is the interface for say colorization, right? So there is one for colorization, there is one for enhancement. All these boxes, your rescaling factor option, this output image option, all of that is what we are interfacing. I mean, we are creating here. So we call in the colorize underscore image function, and within this we call the file path here, and we give the label input image. So this is the input image label. Then you have your output image where the output is being displayed. You also have an option to download the output file. So if you go and scroll down here, you can directly download this image using this download option that is available. And the description is colorize your black and white grayscale images, which is showcased here. Then for upscaling and enhancement, you again have your file path set. Same way you are showcasing the label for rescaling factor, which is already set to 2. So we've set it by default to 2, and then your output comes in the adjacent box. You get your output image here, and an option to also download the output image. All these both are combined in a combined interface within tabs. So we used the tabbed interface, one for colorization, one for interface, and the title remains is image restoration. So your title is image restoration, and all these both are in the two tabbed interface. And then we launch it in the browser directly. So we checked your colorization. Let us check an image for enhancement first. You may choose any image. I will choose this blurred image of sorts, and then try and submit it to the mod. So I just have kept the rescaling factor to 2 only. If you would like, you may also increase the rescaling factor. Accordingly, the resolution of the image would increase when you download it. And that will obviously help in getting to a higher quality image. So that is also a very interesting thing that could be done. As this model is loading our output image, we will quickly go and do a simple code snippet exercise on how you can convert a grayscale image, how you can convert an image into a grayscale image. So for that, I will open a new Jupyter notebook, and also I will head on to kandi.openweaver.com. This helps you jumpstart your application development by helping you find for suitable functions, any code snippet, libraries, kits, etc. So let's say I want to convert image to grayscale, and I want to use the OpenCV library. So I've mentioned that as well, and hit enter. And then I go to this code snippets here. I will remove the filter, and then I would see a very varied amounts of codes that are available. So I will choose the code that I think is relevant. I can copy it. The dependencies are also mentioned for what library may be required. So you just copy paste it, and then load an image from the same folder here. So let's say I use another image that I want to grayscale. So I will go to my kit, Candy Kits, image restoration, and within this pick up any I will pick up a dog image that I have, and the format is PNG. So I will go back, call it dog.png, and control and enter. So this is the grayscaled one. I want to showcase you first this image that I have referenced. This one is the colored one, and we could simply just colorize it, decolorize or grayscale it with this this grayscale one. So that is here, and if you see your output, which has already come, let me showcase you the output. See, look at how blurred this image is, and how it has been enhanced pretty much. So if you increase the rescaling factor, let's say I increase it to 5. Currently the size is in KB, and I'll submit it. and see that I will get an enhanced sized image. So I was trying to showcase you the output. This is pretty clear from what we previously had, and this is also another image that I in the very beginning that we were able to colorize. Okay, you can zoom in and check if you would like in detail. And what else, we can also check for some other images for colorization in the meanwhile. So the model does take a bit of time to do the required running, but then with the kind of look at the size, accordingly your image size is also enhanced. Supposedly I want to do another colorization. I will clear this here, go to the colorization, clear this one as well. Let me try colorizing any other image. Even you could give me an image that you would like to colorize. Let's say, let's choose this kid's image and submit it and see what happens. Okay, so all these kinds of image restoration is possible with this model, and it is pretty clear, you know pretty clear to a decent output that you would expect. This is the output folder that got created. Here you have your model weights, so you can go ahead and check this out and also perform the simple code snippet exercise that I showcased you in today's session. So we'll just wait for this image to get a bit colorized and see what kind of output we are able to fetch from this 𝗖𝗲𝗍𝗂𝘂 model. So for both we have used different. For the facial prior is used for the enhancement, and colorization is used for these images. So the good thing is you can also use enhancement for AI based generated images. So you see that it's trying to get as close as possible to a decent colorization here. Depending on what images, either you can first enhance this image and then colorize it so that you are able to get a better output here. So that is also possible. We will also do one more enhancement of the image. Let's say, let's enhance this image, or maybe we can pull up another image. Let's say I'm thinking to use an AI based image. This looks already really good, but let's say I give the scaling factor to 2 and see. This is not any person, but supposedly based on an AI platform that are generating images for me, say for Tom Cruise or someone. I can actually make it look a little bit more real through this image enhancement model that we are currently working with. So that sort of a thing also you can do, that your AI generated images could also be enhanced to look a little bit more realistic. So we'll just wait for the results to showcase. See, if you see, it has actually tried to make the eyes a little bit more realistic. So that's what I'm talking about. I mean, this has a lot of scarf and all that element to it, but now it looks more of a real eye. So you can actually put in some generative AI based images here and enhance those using this amazing model that we have showcased. So I hope we are now open to some questions from you guys, and let's take up some quick questions from you. So we have one question coming up from our community members, wherein a member has asked, "What is the primary focus of the GFP-GAN generative facial prior model, and how does it enhance low resolution images? So the primary focus on image is on image upscaling and enhancement, and then with a specific emphasis on facial features. That's what I was trying to showcase you, right? The girl's eyes looked a little, let's say, artificial. So the model actually enhanced it and made it look a little bit more realistic. So it improves the visual quality, the details of low resolution. If you have a low resolution image, it's going to make it high resolution. And how does it achieve it? It achieves this by utilizing the gangs and incorporating a facial prior. What is your facial prior? It refers to the prior knowledge about facial structures, landmarks, textures, learned from a large data set of high resolution facial images. So what happens during training? The model is pre-trained on high resolution facial images to learn the facial prior, and then fine-tuned on low resolution inputs by incorporating your downsampled images. So by leveraging that facial prior, the GFPN, your GAN model enhances facial details, add missing textures, reduces noise, and generates high resolution images that appear more natural and sharper. That we just showcased uh, in the model that we ran. So that is how we are able to effectively focus on the facial features primarily with your GFP GAN model. Okay, and there is another question that we have here. What are the potential applications of this model for image upscaling? So with this facial image enhancement, I already showcased you that you can enhance your AI based images. But let's say you don't want to enhance your AI for product and fashion photography. If you have your low resolution product images, you can improve the overall visual appeal, the details on the images. It can be used for medical imaging, for low resolution medical images such as X-rays or MRIs. So that can use to assist doctors, medical professionals, so to help in some accurate diagnosis, etc. In satellite and aerial images also you can use this GFP GANs to enhance. That's something that can be a little futuristic. That's a little bit more futuristic, as you may have to refine the model, optimize it a bit for a specific use case and data set. So I think with this we are able to come to the conclusion of our session, where we discussed how you can use Deoldify to colorize your images and use another model called GFPGAN to enhance and upscale your images. So, and all of this can be curated in a single kit called your Kandi kit and used wisely. So, I hope that helps, and thank you so much.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering two very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like, or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.